So here's my variant that I built last summer, this fall, and I'm going to tell you about kind of how I planned in designing it and building it. But yeah, I'll get started. Here's my little show for you. Variacs are kind of industrial tools, I guess, but lots of people have them on their benches at home, and there's lots of different uses for them. But as I said, I'm going to walk through kind of how I built mine and planned it, and this is kind of what some of them look like. I just got these off Google Images, but there's like a drill press because that's kind of what I used when I was making parts of it. But yeah. So maybe some of you have never heard of one, or you're asking what is variac. Variacs are pretty much variable auto transformers, and a lot of people use them by hooking them up to the wall, which is like 120 volts RMS, and then it energizes a core or a winding. And what's different with variacs than normal transformers or transformers that we've learned about in classes is that it only has one winding, and then it's a direct contact where you can sweep the secondary along the core and tap off of it from 0 all the way up to the full winding. What's handy about this is you could have a design where you had like a selector switch and you could like pick off different windings, but variacs, you can turn a knob which mechanically it like changes a wiper position that moves, which gives you a lot more options than just the selector switch for changing like the turns ratio between your primary and secondary, which is how you vary the voltage. There's a company, I don't know if they still exist, but General Radio Company, and they came up with the name variac in 1934, and so yeah, that's pretty much what a variac is. My inspiration for this project, this past summer I worked down in Indiana for ArcelorMittal. It's a steel mill, and I worked in their power distribution group. My boss was the energy engineer, and he kind of got me going and interested in power systems a little bit, but it was actually a cool internship. I got to see a lot of power equipment, and everybody there was into power, so there was a lot of conversations revolving around power. I kind of asked my boss if he knew anything about vacuum tubes, and now I'm more interested in vacuum tube technology, and I'm taking a course with Dr. Beersma. But back then I knew way less than I know now about them, but I was just asking him, and he kind of casually mentioned to me, yeah, if you're going to start working on old radios or old amplifiers, you should get a variac. He didn't really explain why too much, but he just said, everybody, if you're going to do that, you have to have one. So then it kind of got me interested, and I started researching about them and trying to learn. And then after reading, I thought I could probably make one rather than just buying one. And I don't know why, because I might have been able to get one cheaper, but I don't know, I think it looks cool. So choosing the variac, if you go on eBay, there's like lots of different kinds. Most of them are pretty similar though. Like they change with like the voltage you can sweep. So like some of them are 0 to 120, and some of them go up to 140. So I'll talk about it later. But now that I mentioned that, the 0 to 140 you could use like if you were in a band and you were playing at like a bar or something, and their stage, the wall power was like lower than 120 or something. You could set the voltage that you're playing your amp through to be whatever you want it to be, but probably you'd want it to be around 120 or 117 or whatever RMS. And so I actually read online that depending on your wall voltage, you can change the tone of your amp. And so I would kind of be interested in messing around with that a little bit, but I haven't done it myself, but I just read that. Another big concern with choosing your variacs, like the current rating or the power rating, and you can read on forums and stuff how to pick that to see which kind you need or how many amps of current you're going to need. But I think most guitar amps draw like 2 to 3 amps, and then you can kind of have a buffer to get like a 5 amp unit, and that is a 10 amp variac, just because I never knew what I was going to get into, so I just wanted to go with 10. But so yeah, if you're interested in getting one or making one or whatever, you can read about what you're going to be powering with it to kind of figure out what voltages and currents you're going to need. So purchasing the parts, I did a lot on eBay. And kind of the whole thing, it was like a vision that when I was first reading about them, I was seeing pictures of them online. I'm like, okay, if I made one, what would I want it to have? And so I came up with that, but the different parts, you can buy variacs that are like, they come with a case, or you can buy them like this, where it's just a standalone unit. And that's the kind that I got because it was cheaper on eBay. And so that was about 60 bucks. And I have the manual that I forgot to pass around, or not the manual, like the data sheet that came with the variac. And then I also bought some older Simpson volt and current meters that I stuck on there. On the side, I added an outlet box so that you can plug devices like right into it. And then inside there's, or on the front panel, there's like different components like fuse holders and switches and lights and stuff. And so total it came to about like 120 bucks. And I'm not sure if I tried to sell it how much I would get for it, but I'm not planning on selling it, so I don't care. Planning the layout for it, I kind of had to wait until I had all the parts because I ended up using Microsoft Excel kind of creatively and worked out a layout for it, but I can show you that file, which is this. And so I ended up, every time I got a new part in the mail from eBay, I would measure it and kind of create like the part in Excel, and I created these grids to be, each little box was like 1/8 inch by 1/8 inch, and then I kind of sized it all up and moved it all around, and that's how I figured out how big of a piece of aluminum I would need to put everything on to kind of space it out and make it look nice. Another funny thing is this layout is flipped around from the one that I made, and because of the reason that happened was when we were drilling some of the holes, we messed up on one side, so I just flipped it over and it still works, but that's why it's like that. And then how I ended up doing the machining of the aluminum, now I work at the cyclotron, so it's kind of easier if I were going to do something like this again, but back then it's funny how you learn things like over time, but like now I know way more about how to even begin doing something like this. But back in the summer, at the end of the summer and the fall, my fiance's dad works at Roush, and they have like a machining shop there, and I sent him my file with all the dimensions and everything and told him kind of what I wanted it to be. And then next time I went over to their house, he had it all for me with, the holes weren't drilled, like the big ones for the volt meter and the current meter, those ones were drilled out because he had to like machine those out, but the little holes, we did them in his garage on his drill press. So that was fun. So yeah, it's a great resource, and that's also kind of a little plug for like networking. Like you never know who's going to walk into your life, and that I don't know, there's lots of resources out there, so just talk to people and see what they are interested in. Who knows, you might come across cool people with Bridgeports and drill presses in their garage. So the finished product, when I got the machined aluminum back and drilled it all out, everything, I then just started putting everything in and it fit perfectly. So I was really impressed that using Excel instead of AutoCAD actually worked. And after taking 302, wiring up the transformer was a lot easier, and understanding how to read schematics online and get ideas. And then testing it, I took a video with my phone a couple months ago and put it on YouTube, just to kind of see the progress. But this is in my apartment, just hooking it up to a lamp to test the function. And as you turn the knob, the little wiper goes across it and increases the secondary voltage. So yeah, that's fun. So that's one use. If your lamp's too bright, you can turn your lamp down with it. But there's other uses too that I'll talk about in a minute. Another important thing, variacs, or at least the one I have, it's not isolated. I had to buy an isolation transformer that whenever I use it in my apartment, I plug it into. And the reason is because the transformers that we learn about in school, they have like a primary and a secondary winding, and then they're magnetically coupled, not electrically coupled. That protects you, but if you have a variac, or at least the one that I have, it's directly connected, so the primary is electrically connected to the secondary. So it's important to have an isolation transformer so you don't get hurt, because if you touch something in the wrong spot, essentially you're providing the current with a path to ground through your body. And so if you're isolated, it doesn't do that. So some practical uses of a variac, like I mentioned, and I don't know all the uses, but this is just things I've read about, and some of them I've tried. Like I said, you can alter wall power and for like a vintage guitar amp or a radio or something, and it, as I said, it can change the tone, and I still want to try that out. But this I've done in my apartment. You can, if you're careful, you can measure like primary and secondary voltages, just like an open circuit test, to estimate like a turns ratio for a transformer. And that can be useful, like this weekend we're going to a ham fest on Saturday, so if you get a transformer from there and it's not marked or anything, you can do some tests with it and kind of estimate what you bought. This is like one of the biggest things they talk about online when you read forums. If you get like an old amp and you have no idea if it works or not, you're not supposed to just plug it in and flick it on, because you can, if there's a short somewhere, or if caps are bad or something, you can really do damage to the circuitry in it. And so what you can do is plug the unit into the variac, and the one that I built has an amp meter, so you can slowly turn up the voltage. And I've done it because I used to have a transformer that had a short in it, and as you turn up the voltage, the current will just start rising like really fast. Not even that high voltages, like 7, 8, 9 volts, and then the current will just start shooting up. That's a really cool feature that you can use it for, just testing pieces of equipment to see if the circuit's any good inside of it. Another thing that I've read is that you can reform caps, and I need to read more about this, but I've heard that you can plug like an old amp, and maybe if as the way you got it, if you found it or something, the caps would be like ruined. If you plug it in and you can slowly just turn up and I've read people doing it for like 3 to 4 days, where you can just slowly power up the unit, that there's an insulation film that gets put inside of a capacitor when it sees charge, and when you don't use a cap, it can lose this film. And so as you slowly introduce current into the cap, like really slowly, I guess you can restore this film, and then it's called reforming a cap. So that's another use that people have done, but I've never done that, but I guess it would be interesting to try that. Further plans that I have, kind of, because right now it works like it works for how I'm using it, but I want to add a rectifying circuit to it, and I added a switch on the front kind of back when I was designing the panel, because I had this idea that you could like switch between AC and DC on the banana jacks, and that might not be the best design, but that's kind of what I was thinking. Final thoughts, I'd say be creative. If you have an idea of something that you want to build, even if you don't really know a lot about it, it's kind of funny how things develop over time, so just start reading about it or looking into how you could do it. And I know some of you guys have already built projects and stuff, and like you're good at it, so it's inspiring hearing you guys talk about your projects too, but I hope that you kind of gotten inspired seeing how somebody that knew nothing about variacs could build one. Thanks for listening. Do you guys have any questions?
Are there some situations where, say, using one of those and say like doing the sweep thing, you can damage some circuits? Do you know?
I would guess that you could.
I feel like I was always told to not ever do that on a guitar amp. But
oh yeah, like you wouldn't want to do that. Or I'm not really sure about it, because if it wasn't like playing a guitar signal, you might be able to just turn it up. But if it was like on, I don't think you would want to excite the circuitry. But I don't know for sure, but I'm sure there are many ways to damage equipment. Any other questions?
For the reforming capacitor, and you said you didn't have to do much of that. We just leave the whole circuit as is, and of course just power it up slowly over days. We take the capacitor out. Maybe before, just so getting your outlet there.
I don't think so. Like, I think you would have to build some kind of a test circuit that you could do it with, but I've heard of people just plugging in the unit and powering up, but
like Reddit's electronics stuff, they're always like, I think this capacitor is blowing my TV, or whatever replacement. I wonder, is it safe?
yeah, I don't know. Maybe. I like I said, I just have read about it, and it sounds like a really awesome thing if it actually worked. But and I'm sure if you met somebody that's older and they have experience with older electronics and variacs, that they could tell you exactly how to do it. But yeah, I'm not sure. Anybody else? Nope. All right. Well, thanks, guys.